Well, howdy there, y'all. This is a new week, and it's the week for the university to start. And once the varsity starts, all the students, they come home with a new type of an accent that no one can understand. And they wear funny clothing, and if they've picked up some culture there at the varsity. Like, for example, the varsity hat, the glasses, they always have the glasses on. But for today, my ears are the problem, because I cannot hear these accents when my former learners talk to me. Suddenly they talk in a funny language and I cannot understand, so I need hearing apparatus, and this will be my hearing aids. Because if light can go through a lens, like something like this, and then the light gets thrown onto the focus, then this can be a lens as well, but it's a special lens. It's a lens for hearing and for sound, and yeah, I can hear much better now. Well, to test my theory, I bought a mic, a small little mic that I will move closer and further away, and we will calculate where the focal length is by listening to the sound that I will throw onto this. And as I throw the sound onto this, we can determine the focal point. But we're not only going to look at sound, no, we're also going to look at light. And this is a very special lesson to all the technical science learners that do so bad in the light every single year. Please learn the light. It's easy, Marks, trust me. Pro tip. Okay, so change of plan. I'm going to use this mic. I'm going to keep my duck here. I can't make the sound because it must be the same sound every time. Then the balloon must be kept still. Thank you, wind. Thank you, wind. The balloon must be kept still. Thank you, wind. And let's try and see if we can find the focal point. I think the focal point will be here. Versus here. Versus here. Right, now let's move on to light. And for light, I am going to use this and this. Three, two, one. So what happens is every time something comes downhill like this, and you slag it down on the one side, the other side carries on with the same speed, but this side have slowed down. So what happens is the object changes direction. It came down like this, I sort of slagged it down and braked it here, and then it moved like so, alright? So what happens is it came down like this. Then here I slagged it down and it moved in this direction, because as it came down, braked it, turned, came here. So basically, should light come from a less optical density? If the light hits the optical density, more optical density medium equally everywhere, it means it slags down here, here and here at the same time, meaning it will go fast and then slow, and then fast again. So it will slow it down all over equally. This line we now call the normal. That's your normal line, because the light will go on through it, and because it slacks down everywhere at the same time. What if the light now comes in at an angle like this? As it comes in, here it slacks down first. So it's exactly like when this thing was rolling, and what happened is I slagged it down, it will bend. So now it hits here first. This part here slacks down, while this part is still free to move. It moves fast. So what will happen is, can you see it? So the light will come in like this, hit here first, slag down and bend. So the light will bend towards the normal. It bends towards the normal. So as the light comes in, it slags down and it bends towards the normal. But here where it goes out, this part is out now. Can you see it's out? It will speed up and bend away from the normal. Okay, so as my light comes in, this part over here slags down, first 1, then 2, then 3, then 4, and doing so the whole light will now, okay, the outside is still moving fast. So what will happen is, as it's moving, I hope you saw that. So as it's moving, it will sort of hit, and then what did it do? When it hit over here, the whole light starts to bend in towards the normal. But here where it goes out, now this part on the edge starts to speed up again, and now it bends away from the normal, so that the incoming light over here and the outgoing light over there is parallel to one another. Having said that, let's quickly look at what happened with my balloon, and then maybe we can bring this back into what happened with my light. So in the balloon is over here, and as the sound hits everywhere, the sound hitting on 90 degrees over there, they do not change direction at all. They go through and out. This we call the normal. The sound that hits over here, they bend. Can you see they hit here first? This is still going fast. They bend, and they bend towards the normal. But here where they go out, what happens now? This part over here is out first. So now it forms onto, and the same on this side. And we have a focal point. And you could hear things better over there. The sound was clear and louder over here. But now you're going to say, you might have cheated, and we don't know if this is true, even though you showed us before you started with this. Maybe it's all a big lie. Well, for that, my friends, I have proof, because I'm a scientist, and scientists must always have proof, and the proof will be in the pudding. So what I'm going to do is show you how this works, and for that I need light. Now I'm going to need 3 bits of light, like so. I can even go sideways now and show you what's happening here. I hope you can see it. The light forms onto, like expected, they come in and fall onto a focal point over there. Now, everything that I've said so far in a nutshell is, if this is the barrier between 2 mediums, let's say more and less, then if my light will come in straight like this, it will not bend. It will stop here, here and here at the same time, slag down. So it will come in, slag down, go slower. Okay? Should my light come in at an angle though, what hits it first? This part hits it first. If this part hits the barrier, this part breaks, it slags down. This part is still going fast. So it comes in, this part breaks, and this part is going fast. So it will be an action like this. So as it comes in, it will move. And remember, we call this the normal, because it hits and nothing happens. Should it come in at an angle, this part hits first, and therefore it will bend towards the normal. So the angle there will become smaller, because now it bends towards the normal. Right, so it comes in like this, it hits and then bends in. towards the normal. Now, having said all of that, it is now time to start to prove everything that I've said so far. And to prove it, we will look at some lenses, and I have just a gadget for you. So we're going to look at this. Now, I have 3 rays of light, and they are going parallel to one another. Should I now bring in, let's first start off with a block. Oops, nothing happens. Why not? Well, the light hits exactly like we said. It hits like this, and because it slags down equally everywhere, no change in direction. It just carries on straight through. So my first part is true. Secondly, okay, something weird happens here. What can you notice that happened here? Well, as the light comes in, the middle part carries on straight because that happens to be my normal. But on the side, they bend towards the normal. Can you see? And there where they go out, they now bend away from the normal, meaning that all the light will be focused on a point over there, which we can call the focus. We can now go and draw all of this like so. And we can say, if my light travels down a straight line, I can now calculate the angles with which my light deviates. So we can start to do that and get on a measurement the focus. This focus is very important for the image that will form. This is all good and well, you might say, but what will happen if light hits a concave lens? Oh, this is weird. Suddenly the light opens up. This means that no image can ever form on this side, but the image will be reflected and the image will form here. So if we extend these lines backward, the focus will be somewhere here. The focus for convex lens, Vvex, for convex lens, the focus is always in the front. The focus for concave, cave lens is always at the back. Okay, well, in other words, in the front, depending on how you see it, but the focus will be in the front of the lens and the focus will be behind the lens, meaning the image will form this side, behind, meaning the image will form in that the light hits the lens. But we're not going to draw the lens, no. We're going to represent the lens with a line like so, with the middle of the middle being in the middle there, as you can see. So that doesn't matter how I move this, the focus will all the time and every time be exactly there. That is my focus. Now, look at it. My focus stays exactly where it is. Doesn't matter how I move it, the focus stays where it is, exactly there. All right. Now that we've determined this, now we don't need the lens anymore because we've got the optical center. We've got the lines representing the lens. This distance must be measured and then carried over exactly the same distance to the other side, because you always have a focus on that side as well as on this side. Then that very same distance that you've measured for the focus must be extended to a 2f. So you have a f and always you have a 2f. Right. Now, this can be either a convex or a concave lens. First thing you're going to do is you're going to put an object on that side. So let us put an object on this side. I'm going to look at it. So there's my lens, and first I put it there, other side of 2f. So this line here represents my lens. This line over here represents the normal. That is my focus. That there is my 2f. Now when I look at the object Yo, okay, I'm not even going to show you, but I think you can guess it looks small, right? Because it's very far away, it looks small, alright? What if I bring it in on the 2F? Okay. No joke. It looks exactly the same. With or without the lens? Okay, maybe a bit of a magnify. No, it's about the same. Right, what happens if I bring it in here? Goodness me. Okay, this I have to show you. So this I must show. Right. Now, I don't know if we're going to get the effect. Yo. Okay, so now it looks huge. It looks huge, okay? I just want to show you on the 2F, more or less there. Let me just use something there. On the 2F, okay, now it looks a bit, okay, it's now through a lens and a lens of the camera, so it looks a bit larger, but with the naked eye, it's the same size. Okay, let's do another one quickly. Let's move it in before the F, because on the 4F there shouldn't be any image forming. However, this thing is, it will form, okay? But in theory, just know on the F, no image forms. Then over here, it's not really making a difference, because in theory the object forms behind the lens. Alright, so let's quickly go through what we've learned. When my object is placed beyond 2F, it appears small. On the 2F, I try to show you, but on the 2F, same size. Anywhere here, wow, it enlarges. On the F, no image forms, and in front of the 2F, the image does not form behind the lens, but the image forms. It's not a real image anymore, it's a virtual. Anything forming on the same side as the object will be virtual. Anything on this side will be real. So, let's look in theory what happens. If I place something on the F, the lines come in, and where they cross, they will cross here. So basically, what will happen is, should we place the object in front of the 2F, what happens is the first, okay, you know that the middle line here represents the lens. You don't have to draw the entire lens, that is not necessary. Now, when placed in front of the 2F, first thing you do is you go and you measure the same length there, and you extend this line over here. Then that line must go through what? The focus, because it always goes through the focus. Once it goes through the focus, now, you see we're here, now you extend through the focus. The second line goes from that tip through the middle of the middle. In other words, the first line goes straight from my object, which will be, let's say, over here, and I put it down as so there. I extend this line straight through like so, all the way here. I extend that line here. From here, what do I do with it? I take it down through the focus. My second line goes straight from there all the way through the optical center. I extend it, and where the two lines meet up, that exact spot where the two lines meet up will be where my image formed. What did we notice? We noticed that if I put it beyond 2F, the image forming is smaller than the object. This was true. If I put it on the 2F, look what happens. That line gets extended to the lens through the focus, and then that line gets extended right through the optical center. Where the two meet up, it meets up exactly on the 2F, same size, same size. That is also true. On the F, what? Oh, okay, sorry. First, between the 2F and the F, Okay, sorry. Here we have to study ray diagrams. Between the F and the 2F, it will be a real image, it will be magnified, and it will be inverted. Please pause and study and look at them. Then also know the following. On the F, no image forms parallel lines. And then the important one. And this one is very important, it's always there. If placed in front of the focus, then the image can never form on the other side, meaning that it's not a real image. It will be a virtual image, it will be enlarged. Please study this, they always ask it. Pause this and make sure you can draw it. The first thing of importance is that I cannot use this and this as I did when I explained it. No, this is flat. I have to put this down like so, and to do that I need to make this thing an arrow. So I'm going to put it, let's say, look on 2F, you saw that we get the same size thing. So I'm interested between 2F and F. What if we placed it there? I think it's about the same size. Let's see. Yes, it is. And I carry it over here and I make a mark. So now I can extend this all the way here, because we have to remember this represents my lens. Therefore there must be a line towards the lens all the time. Doesn't matter if you're using concave or convex. My second line must go through the optical center. That's just what we do. In all the instances, every single time, you have a line that goes to the lens, and you have a line through the optical center. So doesn't matter what lens you use, that is a mark, and this through the optical center is always a mark. Now we extend this guy through the focus. How did I know to do that? Well, it's easy. It's a convex lens, and the focus, like when the boys try to burn one another with the sun rays coming in here, the focus is on the other side of the lens, and we take it through like this, through the focus, and where the two lines meet up, this is where that's the object, this is where the image forms. Look, the image is now bigger. So now the object versus the image is so much bigger. Therefore, whenever we place something beyond 2F, the object forming is smaller. On 2F, the object and the image will be the same size. So it will be like this and like this. Same, okay? Then, if I take it beyond or in between the 2F and the F, the new image forming will always be larger. On the F, no image can form. Why not? Because when I put it there on the F, look what happens. What weird and wonderful thing will happen. On the 2F, on the F, if I extend this line forward, and I extend this line through the optical center, guess what will happen? The two lines run parallel to one another, and because they run parallel, no image can ever be formed. However, if I now extend it forward, then another strange thing will happen. So if I remember, this line here represents the lens. Now I have my F, 2F, F, 2F. Should I place my object in front of the focus? Yes, I bring this line forward like I always do. Yes, I also bring this line through the optical center like I always do. Now, look what happens. Should I make this line go through the focus, no image will form. But wait. If I extend this backwards, where the two lines meet up, that is where my image will form. And in this case, my image will be a virtual, because it's on that line. This side it's real, there it's virtual, and it will be, if you compare that to the original one, it will be enlarged virtual. In front of the F, virtual enlarged always forms. Let's have a look. Is this true? Yes. If we go and we put something in front of the 2F, oh, a small, and I showed you, it looks small because it's way off there, far away. If it's on the 2F, same size, I showed you. If it is between the 2F and the F, then it's enlarged. That was the one I drew over here because it was enlarged. If it's on the F, now the two lines run parallel to one another, as you can see. No image will ever form. But if you put it before the F, there's my object now. And what happens? My object now will form a virtual enlarged at the... Just a fast recap. So this is what happens when you are using this lens, which is a convex lens, V for vex. Focus will be forming here. Focus will be on this side and on that side. Remember, whenever you're drawing this lens, this line is of the most importance, because this line you must take through the focus and extend it. So this line over here is marks. Marks in your pocket. You extend it all the way to here and then through the focus and down. The second line of importance are not here, but that one is when you take it through the middle, like from the top there through the middle, and you extend it, and where the two lines meet up, that is where your image will form. Note that a small amount is going backwards, because it can be that a virtual can also form with this lens. Then the other one of importance that we were studying was this one. Note for this one, the concave, the image will always form at the same side as the object. Therefore, in the same side of the object, in front of the lens, we will always have a virtual. And then what we've done from here is we've studied some of our real life lenses and what they would do, which in this case I doubt that I'm going to have a success. But yeah, there is my focus on this one. I don't know if you can see it. There's my focus on this one, and also there is my focus. Oh, it's far away. There is my focus on this one, meaning that I think this lens will give us a better understanding of what things look like in real life. So when you look at it through, you can see I can enlarge it. It's enlarged now, or it should be enlarged now. You can enlarge it. So should you have an F and an F and a 2F, remember it's twice the distance. Should they tell you that you place something exactly on the 2F, then you know your image that will form will also be on the 2F on the other side. Same size, all right? For convex lens, should you put something between F and 2F, like so, it represents that you've got an object, and that object will look like something like this, and now the object is placed there. So what do you do? Very important. First line you always extend over here, that is one mark. Second line you always extend through here, through the optical center. Remember, that is a very, very important one. Now that already is 2 marks for you, just there, just for doing that. Then please remember to extend this one through the optical, through the focus, because remember that's your focus. Where the 2 lines meet up, that is where your image will form. By the way, I'm not right here. It should have been through here. So just by that little mistake there, can you see how much
of an impact it will have. Therefore, you must be very careful when you draw these. The image that will form will be over here, and as you can see, the image will be quite substantially larger than what the object is. So this will be image versus object. There you can have a see. All right, but what else will we see? When you put it between the F and the 2F, your object will always look larger. The image that forms will be beyond the 2F, and it will be an enlarged image, but also it is a real image. It can be projected onto a screen, and it will be upside down. As you can see, it will be, it will be the other way around. So if that one is up like so, then this one will be up like so. If my image happens to be in front, let's do another one. Let's quickly do it like so. Remember, this represents the lens. That will be my F, that will be my 2F. The moment I place it on my F, remember that this line that you extend here and this line that extend there, the two lines will be parallel to one another. They will never meet up, and therefore no image will form. Okay, the last thing of importance will be, if you have a lens and you have your F and you have your 2F, the moment you place the object in front of the F, look what happens now. Like always, that line is always there, this line is always there. Doesn't matter if you use convex, concave, those two lines are always there. But now when I extend this one down here, it means that I must extend them backwards, and where they meet up, that's where my image now forms. So in this case, when the object is that size, the image will be enlarged. It will be the right way up, and it will be a virtual image. Right, then the only thing that remains, and this one is the only tricky one. Remember, for all of those, what we've done is I've showed you this now, right, with a focus, and we use this line all the time, and we use this line all the time. The next one that I'm going to do now, lastly, is just this one, to show you how to draw this one. And what we're going to do is, for this one, it's a very easy one. Again, the lens, but now the lens will be a concave lens, not a convex lens. You'll always have your F, you have your 2F, you have your F, you have your 2F. Remember, they must be the same distance. Now, when I place my object anywhere, I can place my object there, doesn't matter. What happens now is I extend this, like always, I extend this, exactly like always. These two lines, always there. You can even show that the light is traveling from the object. These arrows I prefer, please draw them in. Now, for concave, you use the back focus. For convex, you use the front. So this will be for convex lens, because look what they do. Convex, they always form the focus on this side behind the lens. That's why you use this one. But for concave, look what I do. It extends backward, so the focus will not be here, the focus will be here. So now, because this is not convex but this is concave, you say, I use the focus behind. Where the two meet up, that is where my image forms. My image is also the same way up as that one, but my image will always be smaller than the object, smaller, on the same side, and it will be a virtual image. I think that concludes my lesson for today. There's a lot of things that we need to say, but the main thing is that this line here is important and that line there is important. So these things are the important ones, and I think once we know and understand those, and we know how light goes through, lenses and how lenses can be affected by the light, everything becomes easy, and they are bonus marks. People, thank you so much. If you can, please subscribe and also like my channel if you loved it. All of the best. Keep well. Bye bye.